Hello, good afternoon. This is the second out of 3 HHVM talks this afternoon. I hope that it's not too close to what Stefan just did, just a different perspective. And if you observe me closely at some point, at certain points during the presentations, you will see that I am excited about something and very enthusiastic, whereas at other times I will be somewhere between frustrated and angry. I'm at the moment really split, like a split personality of how to think about this thing that HHVM is. And I'm not sure which part of my inner team, if you will, is going to win the battle. So that's going to be interesting. Okay, HHVM, the alternative PHP runtime. I think this is now, I don't know how many alternative runtimes we have for PHP. 2 years ago, I did a presentation at FrostCon. At that time, I found more than 20 alternative implementations of the PHP language. Don't worry, the only real alternative as in it can actually run PHP code is HHVM. So you don't have to look at 20 different things, you just have to look at one. So hi, my name is Sebastian. I've been doing this thing with PHP for a really long time now. I don't know, started somewhere in 98. And I really like to help PHP developers build better software with the PHP platform, with the PHP language and tools around it. You can call me a pain-driven developer if you want, because a couple of years ago, I felt the pain of not having tools like PHP Unit and PHP copy-paste detector. And I waited for a bit, nobody was implementing them, so eventually I built those tools, I shared them with the world, and apparently people started using them, which is good. I have a company, we do everything that has to do with knowledge transfer related to PHP and surrounding technologies, consulting, coaching, training. That's about as much marketing as I'm going to do. And while preparing this presentation, I thought, hey, we are in Germany, so maybe we should do something radically new and start something in German. Even if you're not German, you may have heard of this guy, Goethe, one of our thinkers and poets back when Germany actually had good thinkers and poets and intelligent people. So basically, in case you don't know German, what it says there is, let him who fails to learn and mark 3,000 years still stay, void of experience in the dark and live from day to day. Meaning, if you don't know your history, how can you possibly try to understand the past and maybe even the future? So yes, we will talk about HHVM, but I think it can help to look a bit where we're coming from, how this thing, PHP, actually works, how that led to problems that Facebook had and motivated them to find a solution. I don't know if you know that, but actually we have a really big anniversary for PHP this year. PHP will turn 20 this year. It was in '94 that Rasmus was working on his website, and he built the first thing of what eventually would become PHP. The initial name was Personal Homepage Tools. That quickly changed in '95 to the Forms interpreter, so he got rid of Personal Homepage, which later was abbreviated to PHP. The PHP came back a couple of months later, like 3 or 4 months later, and he called it the Personal Homepage Construction Kit. That's not really buzzwordy or short or catchy. So in '96, he shortened it and it became PHPFI. Personal Homepage Tools, Forms Interpreter, whatever. But everyone just referred to it as PHPFI. And yes, there are still websites or servers out there that deliver websites through PHPFI. You can refer to this as PHP2. It's still being used. Those are some really adventurous people. No bug fixes in 18 or 19 years. but it works. So in '98, 2 students in Israel who were attending a lecture on how to build compilers came across PHPFI. They started using it. They were starting a little bit of a business at a hosting company. Were interning there for summer or something like that. I forgot the details. But they were using PHPFI, and it solved their problem. But they thought, hey, it could be implemented a lot better. So, as the way that Rasmus explained it, he wanted to solve the web problem. He wanted to build websites, and he built PHPFI for that. But he didn't really know and didn't really care about how to properly implement the programming language. So he built it in a really pragmatic way, which meant that, for instance, if you had a for loop, you would, or PHPFI interpreted source code files line by line. So it found a line that had a for statement. Okay, it remembered somewhere here a for loop starts, and then it executed code. It came to the end of the for loop. It checked whether or not the loop has to run again, and then it backtracked lines back to the line with the for loop. That's not how you build a compiler or an interpreter or implement a programming language, but it worked. It's not very fast, it's not very efficient, but it works. It was a good prototype. So Andy and Zeph came along and said, hey, this PHPFI thing, that has potential, but it's implemented poorly. We can do better. And they were just doing this, or learning all of these things about compilers, and they built something and proposed that to Rasmus in '98. And this led to PHP 3. Note the the slash fi is gone, it's now 3. And it was not referred to that at that point, but the thing that Zev and Andy proposed would later be known as the Zend Engine. You can call the Zend Engine 0.5 if you want. For a while, they thought, hey, PHP 3 is much better than PHPFI, but they still took a lot of shortcuts and wasn't really, well, it still could be implemented better, so they worked a couple of years on it. Other people contributed, and then in 2000, PHP 4 came out with Zend Engine 1, and for the first time, the name Zend Engine comes into play as the compiling and interpreting kernel of the PHP runtime. And again, it was not really implemented well. Well, you learn new things, and so on. And in 2005, we got PHP 5 with the Zend Engine 2, and it actually was a lot better than everything that we had before. Yes, it's not perfect, but over the course of the PHP 5 release series, from version to version, PHP has done a really, really good job of getting better with regards to performance and resource consumption. But for some people, that was not enough. But how does the PHP 5 runtime actually work? It's an interpreter, which is not really true because it's actually an interpiler, which is somewhere between a compiler and an interpreter. A real interpreter would be something like Rasmus did in the very beginning. Try to run the code line by line, whereas an interpiler has some sort of compilation going on, taking the source code, transforming it into an intermediate format that can then be executed. So if we look at this really, really simple piece of code, if true, print star. First step that every compiler does is try to figure out which words, which known concepts of the programming language are actually in the source code file. And this is called scanning or tokenizing. And there are tools, for instance, that you can use to visualize the tokens of a PHP source code file. PHP talk is a tool for that, for instance. That's the output of that. And this simple piece of code is transformed in this very first step into tokens. And this happens by reading the source code file character by character, and whenever PHP recognizes something, it emits a so-called token and starts scanning characters for the next token. So we read this symbol, the question mark, the P, the H, the P, And PHP says, hey, I recognize that. That is a topen tag. And then it reads an I and an F. Hey, that's an if statement. And then some white space and so on. Eventually, we have a stream of tokens, a token stream. But that token stream does not necessarily tell us whether or not it's a valid sentence, if you will, of the programming language. That's where parsing comes into play. Do these parts appear in an order that is valid and makes sense? And for the simple example, if true print star, we have a so-called unticked statement, implementation detail. You don't really want to know about ticked and unticked statements. Trust me. I've tried to understand it at some point, and my head almost exploded. Think of it as a statement. We have a statement, and the statement is comprised of an if, then a brace, an expression, a closing brace, and another statement. And our expression, in fact, is an expression without a variable. In fact, it's a scalar, and that's true. So if true. Braces, braces, that's the first part. And then we have a statement that's executed, that's attached to the if statement. Again, it's an unticked statement. We have the opening curly brace, the closing curly brace, an expression without a variable, and it's a print. And I'm not showing everything there because that would not fit on the slide, even for such a small piece of code. And then the next thing that the PHP interpreter does is not do what real compilers like Java-C for the Java virtual machine or GCC for C and C++ code do. They don't go and do optimizations on this representation of the code. They don't even do optimization, or PHP doesn't even do optimizations on that level of code, which is the final format. So after the parse tree, we go down to bytecode. If you've never seen PHP bytecode before, this is what the PHP interpreter internally sees your code like. If you've ever seen assembly language or Java bytecode for the JVM, looks very similar. In PHP, every function or method, including the pseudo main function of a PHP script, which is code in the global scope, is compiled down into a so-called op array. Each op array contains multiple op lines. Each op line has one op code. Last time I checked, PHP has around 200 op codes, operations like basic arithmetic or calling a function, calling a method, creating an object, printing output, stuff like that. Really low-level operations. Jumping around like if statements. Each of these oplines has an opcode, and opcodes can have operands, data, registers, if you want to use a CPU terminology, to operate on. So we have a JMPZ statement, which is a jump if zero. That's the result of compiling if true. That's the operand for the JMPZ. And if that jump is executed, we jump to opcode number 6, which is the end of the file. If we don't jump, we print the star. As we can see here, the print opcode actually has a return value. And since we don't do anything with that return value, it's immediately freed. And in real compilers, the optimizer would automatically get rid of this opcode. It doesn't really hurt us. It starts to hurt us if you run that piece of code billions of times per second, then you actually feel a slowdown. But PHP is an interpreted, or was intended as an interpreted language, so we never really cared about optimizing this representation, because on the next request, we throw the code away and need to generate it anew. We need to scan again, we need to parse again, we need to emit bytecode again, and then start executing the bytecode. This changed a bit with the release of PHP 4, which introduced optional bytecode caching. It took a while until after PHP 4 came out until bytecode caches appeared. The first one was the commercial offering by Zend. It took the community about 1 to 1.5 years for the first open source bytecode caches to come out, like alternative PHP cache, IPC, which was the most commonly used one until last year probably. So what happened last year was that starting with PHP 5.5, which was released in June, we now ship by default an out-of-the-box bytecode cache, which is opcache, or now named opcache, which used to have 10 different names in the 10 years that it existed, was the original commercial product from Zend. So Zend open sourced their bytecode cache, and it now ships with PHP 5. It's really easy. And if you're not using a bytecode cache, change that. Using a bytecode cache can increase your performance by up to 70%. And you don't have to change your code for that. Okay. 2008. What happened in 2008? Well, on the outside, we don't really know what happened in 2008 at Facebook until a little bit later, about 1.5 years later. But Facebook, by that time, had grown to a point where they started to see PHP becoming their bottleneck. They had optimized their databases, they had optimized their network traffic, they had optimized the kernel of the operating system, whatever. And at some point, PHP execution performance was their bottleneck. For a while, they remedied that by hiring PHP core developers working on optimizations for regular PHP, lots of work on APC, on the alternative bytecode cache, was done by Facebook engineers in 2006, 2007, 2008. Brian Shire, for instance, Lucas Nealon, for instance, they did a lot of really good work on the Zend Engine and on APC. But then even that was not enough anymore. So they were looking for alternatives. They evaluated Quercus, for instance, which is a PHP runtime that sits on top of the JVM. Was actually slower for them than the regular PHP runtime, so it was not an option. Looked at various other things, and eventually, during a so-called hackathon, which is a regular event at Facebook, one of the engineers came up with the idea, hey, we also do a lot of C++ development at Facebook for really low-level stuff. And C++ can be really optimized well using modern compilers into really good binaries. So wouldn't it be nice if we had some sort of tool that would take our PHP source code and transform it into C++ code that we can then compile down into native binary? And within the 48 hours of a hackathon over a weekend, he built a prototype that was able to run really, really simple PHP code. PHP code without functions, without objects. But the basic stuff worked. And then he presented that. It was a success at the hackathon, and he got a couple of months to work on making it work for real. And by the end of that period, it was able to run the Facebook code base. It was not really fast yet. Lots of optimizations still needed to happen. But it showed that it could eventually work. Around 2009, in the PHP community, we started to hear rumors. Facebook had already hired some PHP core developers. PHP core developers meet other PHP core developers at conferences or at the bar at a conference, and they talk. So we heard rumors that Facebook might be working on an alternative PHP runtime. Some people were really scared because it's something that happens behind closed doors. They don't talk about it. We don't know if what they are doing will be good for the PHP project or if it will kill the PHP project. Lots of confusion. So in 2010, Facebook did a really smart thing and a really good thing. They invited the PHP core developer community to the Facebook campus to explain them what they were working on. That was at the end of 2009, and early in 2010, they open sourced HPHPc and HPHPi. And this is where the naming confusion begins. So initially, there was no name for this project. Then somebody came up with the name HipHop for PHP. And I've talked to various people at Facebook, and nobody could really explain to me where HipHop comes from, or ask two Facebook developers where it comes from, and you get 3 different answers. It just happened. So in hindsight, now they call their PHP code to C++ code transformer HPHPc, like the first version of HipHop. HPHPc for HipHop to C somehow, whatever, HPHPc. So HPHPc was able to take PHP source code, transform that code into C++, and then you could use a regular C++ compiler to get a native binary. Just to give you an idea, by that time, in early 2010, it took less than 1 second to convert the 80,000 lines of PHP unit to C++ code, less than a second. But then it took, on my laptop that I had back then, 5 hours to compile it from C++ to a binary that I could actually use. And it's really frustrating if at the very end you get a compile error because something is broken in HPHPc. Well, not broken, but a feature is missing that PHP unit required, so you had to start all over again. So I spent a week at Facebook around that time to help the team get PHP unit to run on HipHop. Because by that time already they had almost 100,000 unit tests with PHP unit. And before they rolled out HipHop for real in production, they wanted to make sure that their tests actually work on their new stack. And for that to work, the unit testing framework has to work on a new stack. So that was a really interesting time. In the everyday development work, they quickly realized that just using HPHPc, like you make a change to the code, transform it to C++ and compile it, even if you use 1,000 cores on a compile farm or even more to speed up the compilation process. I mean, that's the great thing about compiling C++ code. There is a lot of tooling around for compiling C++ code in parallel and distributed among many cores and many machines. Even if you do that, it takes longer than changing the code and hitting F5 in your browser. So they came up with a new project in addition to HPHPc, which was HPHPi, the HipHop interpreter. With HPHPi, you were able to press F5 again. Well, why couldn't they use PHP for that? Well, HPHPc only supported a subset of the PHP language. There's a really rigorous coding standard of coding constructs in PHP that you were not allowed to use because they were either really hard to implement when converting PHP code to C++ code, or so hard that it was not really feasible to implement them. And one of them was the eval statement. So they couldn't do with using PHP, regular PHP in development time, and just use HPHPc for deployment. Why? Because a developer might use constructs in their code that are not allowed and then would break the compilation. Yes, that would be found, but not really helpful, not really an efficient way of working. So they built HPHPi that solved the problem. But the problem, or they got a new problem, or 2 new problems. Problem 1, HPHPi was slower than regular PHP. And they didn't want to invest the time and the effort of optimizing HPHPi because they only use it for development time. Problem number 2, and which is the more severe problem, they had a really hard time keeping HPHPc and HPHPi in sync. Different teams working on it, new versions of PHP were coming out, new features in PHP needed to be implemented in 2 places. Didn't really scale. Hogged up a lot of their development resources, and they were not in a happy place. Just to give you an idea what this code looked like, every release of PHP for at least a decade ships with a bench.php script that is used to benchmark the raw bytecode execution performance of PHP. And this is one of the tests that is in there, which looks really, really stupid. And I hope none of you has code that looks like that. But this tests, for instance, how fast loops can be executed and how fast variables can be looked up in zvals and so on. Really, really, really low-level stuff. Convert that to C++, and it looks like this. And then we can compile it to a binary. And that's also, the binary was also one of the problems that prompted Facebook to do something more than just work on HPHPc. Once all these many cores were done compiling, Facebook was stuck with a binary of several gigabytes in size. And they had a problem distributing that across their tens of thousands of servers. They actually used BitTorrent for that. But it took a while. It took a long time to build the binary, and then it took a while to distribute it. They wanted to do it quicker. But to recap what happened until this point, Facebook had a problem. We'll see about what that problem was in a bit, but they wanted a faster, better runtime for PHP. They found a solution. They found the solution of transforming PHP code to C++ code, and it worked. It worked for them. They could have stopped at that point. They didn't, which is really great because they open sourced their solution. Now, whether or not that solution fits a problem that somebody else than Facebook has is up for everyone that does web development or hosting to decide. I don't think that many people have the problem that Facebook had. Usually, you have to wait for external systems, like a database, and it doesn't matter if you wait in PHP or in HHVM for the database. Waiting for the database is slow in any language or in any architecture, so that doesn't really matter. But Facebook's actual problem was data center cost. And you could really see, well, they're not talking in actual numbers in what data center cost and energy cost they're dealing with in dollar values. But in their press release or in their press presentation in February of 2010, they said, well, we see a reduction of 50% in CPU usage when serving equal amounts of web traffic when compared to Apache and PHP, or Ape, as they were calling it internally, their old stack. They were not running on LAMP, they were running on Ape, Apache, PHP plus extensions. Or if you ask other developers, it was APC plus PHP plus extensions. Doesn't really matter. They were using PHP 5.2 and APC at the time when they replaced the PHP runtime with their own. And Facebook's API tier was able to serve double the traffic with 30% less CPU. And that meant that they could turn off a lot of servers, which means a lot of less energy and lots of less cooling, and that was their problem. They found a solution, they open sourced the solution. Kudos for that. And around the same time that they rolled actually out HPHPc into production, they did this gradually over a longer period of time. Started with 1% of the servers running on HPHPc and the rest on PHP 5.2 plus APC, and increased the amount of servers that were running on HPHPc over time. But around the same time, they also already realized that HPHPc will only be a short-term fix. It slowed down the development process, and they saw that there was potential for even more resource consumption reduction and for even more performance improvements. And that's why they started already in 2010 to work on HHVM, or the HipHop virtual machine. From 2010 to 2013, Facebook used HPHPc in production without any major problems that I'm aware of or that came out into the public. They were happy with it in production, but once again, only after the binary was built and put into the production, they were happy getting their really slow development process not happy. Since 2013, they are actually using HHVM in production. They are very happy with that, and they're continuously improving the performance and the resource consumption. Have big plans at the moment to support ARM 64-bit CPUs, which use less power than AMD 64-compatible CPUs. So that's going to be really interesting. So what's HHVM? HHVM is an open source virtual machine designed for executing programs written in Hack and PHP. Open source, I don't need to explain, hopefully. Virtual machine, I may need to explain. Virtual machine is a piece of software that is able to run a piece of software, interpret it in some way. The PHP interpreter, and the lights went out. Is that a problem? Good. Just don't fall asleep. The PHP interpreter is a virtual machine. It's a piece of code that executes PHP code, and it's a black box you don't really care about unless you are someone like me who gets excited about compiler design, language design, compiler implementation, and so on. It's a black box that executes your code. Lots of interesting technology in there, but it just works. The Java virtual machine is a virtual machine that executes Java code, and so on. Executing programs. The last bits are really interesting with the order in which Facebook puts it, written in Hack and PHP. Hack, we'll get to in a bit. PHP, we all know, hopefully. So, how does HHVM work? Works to some extent very similar to what PHP does. It starts with tokenizing, because that's what we have to do. There's no way around that. Then it doesn't build a parse tree like the one that PHP uses, but it builds a real abstract syntax tree. And there are already on the abstract syntax tree, you can do a lot of static analysis and optimization. And talking about static analysis, that is something that I was really excited about when I visited Facebook last year in fall and saw what they were working on back then. Come to that in a bit. After the abstract syntax tree, the source code is transformed into, and warning, this is now really techno-babble, buzzword bingo bullshit, typed static single assignment intermediate representation. So what does that mean? An SSA, or a static single assignment form, is a highly specialized representation for code while you are compiling code. Has some really interesting characteristics in that every variable that's used, once it's in this form, has to be declared and can be defined only once. It doesn't change, it's static. Sounds weird, but actually makes sense. Don't want to bore you with the details. It allows some really, really nifty optimizations and analysis methods. It's typed for every variable that's in this representation. We know its type, which again, really, really helpful. If we know that the variable is always an integer, we can, in our underlying data structures, actually use a native platform integer. Much more efficient than, for instance, what we're doing in PHP, in the PHP interpreter, using a Z-val, which can be anything. It can be a string, it can be an object, it can be an array, it can be an integer. Really, really flexible, which is what you need in a dynamic language, because from line to line you can change the type of your variable, but not really helpful when you try to optimize code execution. And this couldn't really work without this type inference. Using the code analysis, HHVM can figure out while compiling the code, yes, this variable actually, wherever it's used, it's an integer, so it can use that. It infers the type. Really useful. Talking about static analysis, while HHVM is compiling the source code, it generates a JSON file in the temp directory that is not really documented. I hope that this functionality is not going away at some point, because there's so much useful information in a JSON file about warnings and errors and ambiguous stuff that it finds in your PHP code while it's transforming your PHP code. And I wrote a tool called HHVM wrapper that wraps around the HHVM command line thing, command line interpreter, that generates behind the scenes this JSON format and gives you access to the information in there. And I actually have some homework to do because this is output from running HHVM wrapper on PHP unit. There are at least 3 valid potential bugs that it found. So that's a really nice side effect of the typed SSA, IR, and the type inference and the static analysis built into the compiler. Next step after the intermediate representation, because we don't just stop there, is we generate bytecode. And we don't generate PHP bytecode, but HipHop bytecode, which actually has a specification which the PHP bytecode does not have, which is good because you can read it. You can write your own interpreter for HipHop bytecode, for instance, if you want. Also helps with hacking on it because you can actually read what's going on. There's some really interesting implementation detail in that the HipHop bytecode is written to disk if you're working in repository mode as a SQLite 3 database. So you can compile your whole application into a single file that only contains the bytecode, and this file is an SQLite 3 database that can even store versioned snapshots of your application. So you just have one file, but multiple versions of the application in it, and you can say, I want to run version X, and new requests get version Y, for instance. Make some really interesting deployment concepts possible. But it's also really interesting because you have a really structured format for the binary representation of your application inside a relational database. Using SQL, you can ask questions about your code. What classes do I have? Who calls whom? Crazy stuff. It's a fairyland for people that like to do static analysis. Makes it really easy. Well, not easy, but possible in a different way, in a new way. If you get excited about these things, then you understand. And then what happens after that is just-in-time compilation, which is why it's getting really, really fast. So while the code is being executed, it gets translated into machine code. Not everything is translated to machine code at first, only the sections of the code that are actually executed. So you start obviously with 0% being executed, and then you have a request. The request uses about 10% of your code base, and those 10% are on the fly transformed into machine code. And machine code can be executed really quick. And then it's cached. You don't need to care about that. Just works. Well, you get native machine code in the end, and that is really fast to execute and really efficient to execute. Performance. It's really hard to talk about performance in an objective way. It's very subjective. Google for HHVM and benchmark, and you find many different things. Some people will say PHP is faster for my application than HHVM. Most people will say HHVM is faster than PHP. This is, well, the official benchmark from Facebook, measuring the Facebook code base. And for them, HHVM is first and foremost twice as fast as HPHPc was. And this was with the first release. And since then, they have optimized from release to release, so they're getting better. It's 9 times faster than Ape was for them, PHP 5.2 plus APC. Uses up to 80% memory less than PHP 5.2 and APC did. So they are getting what they want out of it. Less resource consumption and higher execution speed. Or CPU efficiency, if you want. So in case, well, I have to have a little bit of PHP unit in the presentation, even if it's just on HHVM. So, and since I already got the question yesterday in another talk, yes, PHP unit runs on HHVM. So for instance, this is regular PHP 5.6 running a test suite, and it looks very similar if I run the test suite with HHVM. And do you spot something? Is there something curious? What's curious? It's slower. Yes, that's because this is not fair. Do it again. That would be correct if we were actually running in the web server. This is a command line tool. And at the end of the request, the memory of HHVM is gone, so we cannot cache the native machine code. You can get it faster by turning off the JIT, because then you don't get the overhead. HHVM does not do all the optimizations that it can do. And then it's faster than native PHP. Which sounds weird, because when you're not optimizing, then it's faster. But it's not weird at all. If you're not optimizing, you're not wasting time. And in this case, PHP is faster because it doesn't optimize. It just goes straight to executing. Well, scanning, parsing, bytecode emission, execution, whereas HHVM has 2 or 3 phases of optimization in between that we don't need and don't get the benefit of on the command line. Okay. Framework parity is a really big topic for Facebook, or they like to talk about it a lot. What it means is that they want to be as compatible with PHP as much as possible at this point in time, at least. And the way that they ensure that is that they look at the top 30-something PHP-based applications and frameworks on GitHub. And for every push that they make to HHVM, they have a Travis job somewhere or a continuous integration job somewhere that builds HHVM and then uses PHP unit to run the test suite of this top 30 whatever list of frameworks, like Symfony 2, Zend framework, Doctrine, PHP unit, whatever. Run them and make sure that those pieces of PHP code work on HHVM. That's framework parity. 2014. Facebook open sources Hack. And Hack is a programming language for HHVM that interoperates seamlessly with PHP. It reconciles the fast development cycle of PHP with the discipline provided by static typing, while adding many features commonly found in other modern programming languages. So suddenly, Facebook had a new problem. They wanted to have the fast development cycle, the rapid development cycle of a dynamic language such as PHP, without the risks attached to a programming language that is as dynamic as PHP. So they introduced things like static typing, or a concept called gradual typing. And for instance, you can, with Hack, define a return type hint and say, this functional method, it returns a Boolean, and get an error message when it returns something else. And the really interesting thing is that they have a tooling around it that while you develop code, while you're working on the code, it can report errors that you're making in your code, that you're violating some of your constraints that you have put in place. Makes developers much more productive because they spend less time debugging, and you don't run the risk of getting errors in production that you can only get at runtime and are likely to miss using conventional testing techniques. Collaboration with the PHP project. In PHP 5.5, we got generators. Generators were implemented first in Hack before we even knew that Hack existed. It was just a syntax edition at that point that was available for PHP in HHVM. And at the time when PHP developers started to discuss generators, Facebook engineers came around and said, hey, we have implemented that. This is our syntax. If you want to adopt it, that's great. If you opt for a different syntax, that's also great. Then we adopt our syntax to yours, because we have the tools in place to do an automatic refactoring of our code base to change the syntax of that feature. And that works. So they are cooperating. Lots of PHP core developers now work for Facebook. They still care about the PHP project. They communicate, and that's nice. However, not everything is nice. And my presenter thing is telling me by vibrating really wildly that I'm out of time, but please allow me 1 additional minute for a little bit of a ranting. I mentioned earlier that I'm really split. I'm very enthusiastic as programming language, compiler, runtime, whatever. Geek, if you want to call it, but I'm also frustrated about a couple of things. So what am I frustrated about? When I first worked with HHVM, I was really, really excited that I was able to do something like this. And last October, this actually worked. What does it do? It gives me userland access in PHP code to abstract syntax trees of PHP programs. Yes, I have something similar available written in PHP for PHP by Nikita Popov. But the problem with that is that it's not automatically in sync with the syntax of the language. If a new feature is added to PHP, Nikita has to work on PHP parser to extend it to teach it in the new syntax. And here, it's built into the runtime. When I add a new feature to the runtime, like a new syntax feature, it's automatically exposed and accessible through what they called the Code Model API. So that made me really excited. And I started to work on new tools that use that information for static code analysis, software metrics, automatically finding bugs in code, and so on. Automatic refactoring tools. Really, really interesting stuff that I have wanted to work on for a really long time. And by the way, this would be like the first 20 lines of output for that. You get an object graph where each object represents one node in the graph. You can rearrange it and then serialize it back to PHP code if you want. Really cool stuff. And then in March, it was removed. And I was really surprised by that. There was no warning. From one commit to the next, it was gone. And the explanation was the author of code model left the team, and nobody else understands the code. The code led to problems. We don't need the code. We deleted the code. And that really makes me angry. The first problem that you run in, you give up. You don't even ask if somebody could help with that, they remove it. Yes, of course, it's in the version control. Somebody else can pick it up, go back to that revision, try to fix the bug. But if it's deleted and nobody talks about it, nobody will know that this existed at some point. That's scary. Also, at some point, code coverage functionality was added to HHVM. And of course, I wanted that. I asked them to implement it, and they implemented it. And I started using it in PHP Unit, and PHP Unit, if you run it on HHVM, can give you code coverage report for your code that you run on HHVM. But I found bugs, which is not surprising in a new feature. I opened the bug. Response was, thanks for reporting this. Nobody has looked at the code coverage code in a long time. It looks like the last non-cleanup commit in the code was about 22 months ago. And that really scares me. I don't know how they get code coverage for their own code. And I can, to some degree, I can understand, not that I find it good, their reasoning that they remove features that they don't need. I can understand that. I don't like it, but I can understand it. But I cannot understand why they would remove this. And I don't know what's going to happen in the future. They have not fully converted from PHP to Hack yet. But eventually, their entire code base will be Hack, at which point they will wonder whether or not they still need to support PHP. So on the one hand, I'm really excited about HHVM. On the other side, I don't know how committed they are in the long term to support PHP besides Hack. I mean, if it's okay for you to migrate your code base completely from PHP to Hack, or to use Hack for new projects if you want to use the HHVM, then you're fine. But if you look at HHVM today and just want to get the performance benefit out of it, and your current PHP application works on it, which it probably will, and you make the decision to switch the runtime, then at some point in the future you may need to switch again because they drop support for PHP. So that's why I'm a little bit confused between very excited and enthusiastic and frustrated / angry. But that's probably just my problem. I don't know. So thank you for your interest in this. I hope it was useful for you. Next talk in this HHVM mini track will be by Arne, and he will show you how to install and configure HHVM in your system infrastructure integrated with Nginx most likely, and get you started in using it. Thank you.